Try except blocks are a very powerful method in Python to catch exceptions, to catch these issues during runtime of the program, ensuring that we can control how the program fails gracefully. In other words, if we are expecting a potential issue, we can control the outcome if that issue arises. And that's with, again, these try except blocks. So this is a big component of handling our errors in Python. We're going to spend some time talking about that. And here I have a screenshot showing the format of our try except blocks. And you'll notice I've got my lines back on a Mac with the screen brush tool, which I hope is helpful for you to see, highlighting some things. So in Python, this construct that's built in for try except is as follows. We say try, that's a keyword in Python. Then our colon, which often, remember, when we have a colon, we mean indent. Something is part of this block. So whatever's indented right under this try block will be code that may raise an exception, that we expect could raise an exception. And so if this code, whatever is in this indented block under try, does raise an exception, in fact, then we execute this except. Except, that's the other keyword there. We execute that and we do something to handle the exception or to control how that reveals itself. We can create a variable here, some exception or whatever we want to name this, or exception, and we can say assign that to variable e if we'd like, and then we could say print e. So if we just wanted to print the exception, we could do that, and I'll show you that here in a second. But we could also, as I show here below, just catch the specific exception if we know what exception it will be. For example, a zero division error, that's an official Python exception. Then we can say, so we can try running this code, which is 10 divided by 0. If that causes a zero division error, then we can say print cannot divide by 0. So if we specifically know the error type, we can do that. So there's a couple different ways of doing that. And let's look at some exceptions here. I've just Googled Python exceptions, found the Python documentation for these built-in exceptions. And if we scroll, we see there's quite the list. Arithmetic error, lookup error, attribute error, import error, index error, key error, name error, etc. So I've highlighted about 10 exceptions previously that could occur in the previous video. But there's a lot of different errors. And one of them, file not found error. I'm going to show you an example with this. If we're trying to open a file, but the file does not exist, we can see that exception. So let's go back over to Visual Studio Code and look at this in practice. So we have our try. We can run this. We say cannot divide by 0. That's the output. Because 10 divided by 0 is a zero division error. So then we print cannot divide by 0. If we did 10 divided by 5, what's going to happen? Nothing. We don't actually have any output. We could print that here. Print result. Let's run it again. See, we print 2.0. So this try block executed without an issue right here. But if we change that to 0, we're going to get a zero division error in this try block, which will trigger this except clause and the subsequent code that's indented here. So if we run that again, cannot divide by 0 because we're just printing cannot divide by 0 in this block. We could also do this method as I've highlighted up here. Let's say except some exception is E. Let's just say, if we want to be more vague, if we don't specifically know the error, except exception as E, we could print E. Excuse me. Exception as E. Division by 0. This does need to be capital E because it's the base class for non-exit exceptions, as we read there. So we could say exception as E. So this really shouldn't be some exception. It should be exception as E. We could just print the error. So that's another way of doing it. So let's try another one. Let's say open file.txt. File.txt does not exist. So what's going to happen? Let's run it. No such file or directory, file.txt. And let's walk through this with our breakpoints. Let's start our debugger. Okay. So here we are at the try. Let's step over this. Trying to open the file.txt. Let's step over. Accept exception as E. We now found E is given a value, which is file not found error. And then we're just printing that, as you see. So with this, we have two ways of doing it. We can say try except exception as E. We could name that anything. We could name it blah. We could print blah. Accept exception as E is kind of the standard way of doing it. Or we could say the specific exception here. So as we were looking at in Chrome earlier, file not found error. I love how our IDEs help us with these things. We could just say except file not found error. Print file not found. So let's run it again. I'm going to get rid of that breakpoint. File not found. So this error was clearly caught. If we try something like index error, we don't actually catch the error. We don't catch it preemptively. Python tells us about the error, and it terminates the program. It says file not found error. And this is the traceback, the call stack. So we didn't handle the error. See, we're not printing file not found. So we're not controlling what happens when the error occurs here. Python is catching the error for us, which is sometimes okay, but often we want to preemptively catch these errors. So if we say file not found error. So whenever we're opening a file, I could say like with open file.txt as my file, print my file.read, except if it's not found, print file not found. This would be a good practice anytime we're opening a file to use a try except block, because then we can control what happens here. So that's an introduction to try except. We'll talk a little bit more about it in the next video, but definitely a powerful mechanism to help us more appropriately debug things.